Hey guys, welcome to this video, and from this video onwards we'll be trying to find out the actual value of gamma of half, and we'll be trying to give you some properties on the Euler's reflection formula and if possible a proof of it. So let us see how do we achieve that goal. So let me just recall what we did in the previous chapters. What we did was as follows. What we did was we found out that gamma of n is equals to n minus 1 factorial. What we also did was to find out that gamma of z for a complex number z is 0 to positive infinity, and this holds for all z not equals to 0 basically, because since it's complex numbers, we do not really want to indulge us with any kind of restrictions, but rather what we would like to say is that this holds for all z which is not 0, because what happens for gamma 0 is because it diverges to negative infinity, right? So we cannot hold it. Now there was a recursion value for all real numbers, which is just gamma of s equals to s minus 1 into gamma of s minus 1, where we had s greater than 1, right? So this was also some of the properties we had, and lastly what we saw was gamma of n by a to the power n is just the integral 0 to positive infinity e to the power minus ax into x to the power n minus 1 dx. So these were the properties that we had found during our course of lectures for the gamma function, and I have also told you before that the gamma function can also be evaluated for fractional values, right? So let's say for half integer values, which is more common. So half integer values more often than not comes in place of gamma functions, and we can evaluate them, but what we need to understand here is how to evaluate those half integer values. So I'll get to that, but before that let us solve an integral. So evaluate So for example, you are given this integral and you said that n belongs to natural numbers, at least for this integral. So how are you going to evaluate this? So to give it a try, I'll give you 10 seconds to try, and then I shall do it on my own. Okay, so I hope you have tried it already, because this problem is not really hard one if you understand what you need to do, because in this problem it is given that 0 to 1 minus of ln x dx, and where minus of ln x has a power of n, right? So this means that we can basically understand that this problem comprises of the fact that log of x must be substituted, right? So let us do that and hope for the best, because what I can see from this problem is, let us denote the integral by I, and we also understand that upon substituting we should get something familiar, because obviously this thing here right now here is not familiar, because we do not know how to find out derivatives of log x whole to the power n. So what I will do is I'll show you different methods for doing this, maybe in two consecutive videos, but I'm going to show you to do like two different methods for solving this particular integral. So now let y equals to minus log x. Now understand the fact that log of x is or maybe ln of x here is negative inside the interval 0 to 1. That is why n minus ln x makes sense, because otherwise the answer would be negative. So what we have done is we have used minus ln x so that we have a positive quantity to the power of a natural number. So when you have y equals to minus ln x, dy should be minus dx by x, because 1 by x is the different derivative of log of x. Now since we have this part, what we can do is dy equals to minus dx by x, and the limits we shall see that y lower should be equals to minus ln of x lower, right? Now minus ln x lower is just 0, and we know that log of 0 is negative infinity. We have talked about it earlier. So this will just give you minus infinity, which is positive infinity, right? Similarly, x lower, what I mean is y upper would be equal to minus ln of x upper, and this would be just 1, and log of 1 is 0 as we know, so this becomes 0. So what the integral turns into is as follows. So the integral after the substitution is as follows. I is equals to, so the lower limit is positive infinity, the upper limit is 0, and minus of ln x is y, this is n, and dy dy just becomes minus dx by x, or what you can say is dx is minus x dy. Now we know x here, because we understand that minus y is equals to ln of x. So x should be equals to e to the power minus y, because ln means natural logarithm with the base of y, right? So what we do have here is we can write this integral as this minus would change the course of the limit, so it will become 0 to infinity, 0 to positive infinity, y to the power n, and this would become x dy means e to the power minus y dy. And as you can see, we have reached our goal, because this is a form that we already know, right? Because this is the gamma function, and to understand it, what argument of the gamma function it is, we need to write it in this form: n plus 1 minus 1 e to the power minus y dy. So this would give you gamma of n plus 1, and since it was natural numbers, we know this should be equals to n factorial. So therefore, remember this definition of factorial: 0 to 1 minus ln of x whole to the power n dx is equals to n factorial for all n belongs to natural numbers. Or you can also say like including 0, but that's not required, because we all know that 0 to 1 dx is 1. So this one is a more familiar definition. Okay, right. What you can also understand from this definition is 0 to 1 log x whole to the power n dx would just be n factorial into minus 1 whole to the power n, because you see this minus 1 whole to the power n can come out and get divided here, and dividing by minus 1 whole to the power n is same as multiplying by minus 1 whole to the power n. And minus 1 whole to the power n, if you see clearly, if n is even it gives you 1, if n is odd it gives you a minus 1, right, which is basically the signum function. So what you can write is this is equals to signum of n into n factorial, or the sine of n into n factorial. So if the sine is odd it will give you odd, it will give you even otherwise, right. So this will be basically our lecture for this video, and in the next video we shall try to figure out the different representations and the Euler reflection formula for ultimately finding gamma of half. Then we shall move on to the beta function, and finally when we are done with all the functions we shall understand how to do the distributions of them separately. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.